This lesson's for week 9, lesson 11. This time, on this particular lesson, you are going to be given a series, and you are going to have to try to write it in sigma notation. Okay, meaning you're going to have to write the symbol down here. Just to make this easy, we're going to always start this at 1. It doesn't have to always be 1. But again, this is sort of an introduction into sigma notation. So for our lesson, it's going to be a 1. The top number is going to let you know how many numbers there are in your series. Some of these, if you're looking ahead, you can tell just by counting, but other ones, you're going to have to figure out how many numbers there are in that series. All right, and then here, right, but after the E, you're going to have to figure out what's called the explicit equation. So you've already seen these formulas, but this is going to be, let me highlight it for you in yellow. This one is going to be the one for arithmetic. Again, not a new formula. We're just going to kind of use it a different way. And then the one over here that I'm going to highlight in red, that one's the geometric. Okay, so I can spell. Oh gosh, this is the last video that I have to record for you for this first quarter, and I'm getting tired, so that's why it's not quite as good as some of the other ones. Anyway, so let's start with example number 1. All right, so it clearly says write in sigma notation, so I'm just going to start with this, and I'm going to put in n equals 1. All right, second thing I'm going to do is I'm going to count how many numbers are there in this series. 1, 2, 3, 4, there are 5. All right, now all I need to know is this, right? What do I write there? So I'm looking closely at this, and I can tell that it is arithmetic. And the way that I can tell that it's arithmetic is that I am adding 2, adding 2, adding 2, right? Every single time. So I'm going to use this formula. So let me put in the stuff that I know. I know the first term is 3. I'm going to leave the n there. All right, you're going to leave the n, and then the common difference is 2. Let me distribute and clean this up. 2n minus 2. If I combine my like terms over here, I finally get to put 2n plus 1. Now, the best thing in the whole world about math, in my opinion, is that I can always check, right? So check it out. Try it out. If you put 1 in here, you get this 3. If you put 2 in there, you get 5. If you put 3 in there, right, it works. You can always double check. It's never a guess. Okay, so let's try this next one. Let me move this up a little bit. Okay, so let's see. Is this it says to write it in sigma notation. Sorry, I forgot to switch to a pen. Sigma notation, n equals 1. Okay, let's see. I can tell that there's 1, 2, 3, 4, 5. There are 6 numbers in this list. So I've got the 1, I've got the 6. All I'm missing is the explicit notation. Excuse me, the explicit equation. All right, so is this arithmetic or geometric? What is the pattern here? Well, the pattern is multiplying by 3. So it has a common ratio, which means I'm going to use the geometric formula. So let me write it up, and we'll plug stuff in. All right, so the first term is a 2. The ratio is a 3, and you leave the n alone, and I've got the whole answer. There it is. That is the series written in sigma notation. Okay, let's try another one. All right, again, getting slightly more difficult. The only difference here is, all right, let me write this up. It says write in sigma notation. Here's my n equals 1. Here's the problem. See these dots? I don't know if that 90 is the 7th number in the list or the 50th number in the list. I just don't quite know. So up top here, I don't know what to put. I can't put anything yet. So let me do my next step, okay, which is to figure out, is this arithmetic or is this geometric? And it looks like I'm adding 5, right? I'm adding 5. So this is arithmetic. So let me figure out the formula. So the first term is negative 10, leave the n in there, and then the difference is 5. Let me clean this up a little bit, which means distributing and combining some like terms. So over here, I now have 5n plus 5. I missed a negative. Minus 15. Okay, do you know how I caught that mistake, by the way? When I plugged mentally, very quickly, when I plugged 1 in there to double check, I didn't get negative 10. So I went back and figured out that I missed a negative. Okay, so now all I have to do to figure out this top number that I'm missing is set it equal to 90, right? If 5n minus 15 equals 90, or if 5n equals 105, or if n equals 21, that will give me that number at the end. That is the last number. It is the 21st number in the list. Okay, so then this last one, again, it says to write it in sigma notation. So I can write this part, but because of these dot, dot, dots, I don't know what position this number is in, right? I can't put 256 up there. It's not asking for 256. It's asking what position is that in. So let me find the formula instead. And this one's geometric, right? You can see these numbers are doubling. R is 2. So here's what my formula is going to look like. It's 2. The ratio is also 2. So let's see. Let me write that up here. 2 times 2n minus 1. All right, and in order to get this number, I'm going to set this explicit equation, sorry, I just stuttered, equal to that number. Okay, so if I divide both sides by 2, I get 128. So then 2 to the n minus 1 is the same thing as 2 to the 7th. Let me double check that in my calculator really quick. Is 2 to the 7th 128? 2 to the 7th. It is. Okay, which then means that n minus 1 equals 7, or in other words, n equals 8. Okay, again, what that means is that this is the 8th number in the list.